So we are live. Hi everyone. Very good evening and welcome back to Geeks for Geeks practice. I hope that all of you are doing really well. Before we start, let me quickly introduce myself. So my name is Yash Dwivedi and currently I'm working as a software development engineer at Geeks for Geeks. Which besides this, I'm a candidate master on Code Forces and 5-star on CodeChef. So guys, please give me a quick +1 in the chat if everything is working fine, and then I will share my screen so that we can start discussing the contest. Also, please let me know how many questions you were able to solve during the contest. Okay. So let's quickly see. Okay. Hi Aditya. Hi Tech Wonder. Hi Jyotish. Hi everyone. So yeah, guys, please give a thumbs up quickly so that I can understand that everything is working fine. And then we'll start with the discussion of this particular contest. Okay. So Aryan is saying he was able to solve 2 problems. What about others? Others can also tell me how many problems you were able to solve. Okay. 1 problem. No worries. So yes, let me quickly share my screen now so that we can start discussing the contest. You can keep on commenting how many problems you were able to solve. Okay, so let's quickly search this contest. That was 148. And these are the coding problems. Okay, so it was very tough. I didn't solve anything. It was tough. Same here. Okay, only one last 2 contest. No problem. Okay, so I think that we can begin now. You can tell me if everything is fine. So yeah, let's start discussing all the problems one by one. In this contest, I will say various topics were asked. For example, the first question was quite easy. It was based on the hash map concept. Second problem was a little bit mathematical in nature. First problem basically was related to hashing, right? Then if you will see the second problem, that was kind of related to a little bit of mathematical concept and observation, because you had to see if you are doing modulo, so how will you minimize the array size at the end. Okay, then after that, in the in this problem black tree, it obviously it used a DFS approach. And then last, if you will see maximum cost, so this problem was also a normal problem only. Obviously you can say it was a, these problems were quite medium to hard level, but still I would say they were not that tough. Okay, so let's and you can see maximize the cost. So you have to do what you can see here, that you want to maximize the total cost of the gift. So obviously there is one algorithm that should come to your mind. If it doesn't, so I will explain you about it. Okay, so let's quickly start discussing the contest now. Everyone is ready? Please give me +1 guys in the chat, and then let's begin. I guess everyone has joined now. Okay, and for those who are joining right now, they can tell me how many problems they were able to solve. Okay. Aryan Chandel. Yeah, I will discuss that, but as of now, I don't want to disclose. So yeah, maximum split. Let's see the first problem. That is nothing but maximum split. So the first problem is basically maximum split. Okay. Now in this particular problem, they are saying that consider 2 string S and T. Both are anagrams. So there is a string S given to you and there is a string T given to you. Both are anagrams. Okay, what is the definition of an anagram, guys? Right, what is the definition of an anagram? So basically the definition of an anagram is 2 strings are said to be an anagram if both the strings have frequency of every character like same. So basically suppose that string 1 is like what, let's say you have got Y, then double A, then S, and then H. Okay, now suppose that the string T is there and it is containing what, it is containing A, then S, and then H, and then Y, and then A. Okay, so both of these strings are anagram. Why? Because if you will see the first string, so here you can say that A is appearing 2 times. Okay, then after that you can say Y is appearing 1 time, H is appearing 1 time, S is appearing 1 time. Similarly in the second string, if you will see, so A is appearing 2 times. Okay, S is appearing 1 time, H is appearing 1 time, and Y is appearing 1 time. So basically, say, like you can see that all the characters occurrences are same. A is occurring 2 times here, A is occurring 2 times in the second T string also. Y is occurring 1 time, Y is occurring 1 time. then H is occurring one time in the first string S, and then after that you can see in the second string also H is occurring one time, S is occurring one time, and S is occurring one time. So same characters are present with the same frequency. Their order might change. So is that clear? What is the definition of an anagram? So this is the basic definition for an anagram. Now furthermore, the problem says what? Furthermore, you can see that problem says that geeks want you to partition both the strings into k non-empty segments. So what you have to do is you will be given the strings. Okay, suppose you have been given the string S and you have been given the string T. So suppose this is the string S and this is the string T. So you have to do what? You have to bifurcate both the strings into some segments. So let's say you will break it from here. Okay, so let's say this is the first segment. If you will start breaking, so let's say this is the first segment that you break, okay, of the same length. Then after that, let's say this is the second segment that you break, okay, of the same length. Then after that, let's say there's a third segment that you break. Suppose that you are breaking them into three segments. So basically what they are saying is that in this particular segment, like what should happen basically is in the first segment, right, in this particular, like in the first segment, all the frequency of all the characters should be the same, right, in the S string and T string. Then in the second segment, the frequency of all the characters should be the same. Then you can say in the third string, the frequency of all the characters in the third segment of first string and in the third segment of second string should be same. Is that clear? Please write yes or no, guys. Are you clear with this part? I will explain this using an example as well, but so far are you getting my logic? What is the requirement in the question? Is everyone clear with that? Yes or no, guys? Please tell me in the chat. Okay, if you will see here, suppose that you have got the string S, okay, and you have to do what? You have to try. Also, one more thing, the problem says that you have to try and break this string into maximum segments. Okay, you have to try and break this string into maximum segment. And basically when you are taking the first segment now, so first segment, that is this red colored segment in the string S and T, both should have the same frequency for each and every character. Okay, basically kind of they should be anagram in themselves. Then second segment that you are breaking, the yellow segment, so basically both the segments should have the same frequency of all the characters. Order might differ. Again in the third segment also, if you're breaking, then both the characters should have the same frequency. Both the strings should have the same frequency of characters. If you will see here, suppose that you have got the string S, okay, and the string S is like A, suppose, okay. Then after that, let's say this is the first string and the second string is what? Let's say it is nothing but something like A again. Okay, so I have to do what? I have to break it into maximum segments. Okay, because I want to maximize my answer, I want to break this string into maximum segments. Understand this thing very clearly. I want to break the string into maximum segment. So you can see here that this would be the first segment that I can break it into, because here the frequency of the characters are like here overall frequency is same, right, for all the characters, because you can see in this segment A is appearing one time for the first string, if you will see. So I can maintain two maps. A is appearing one time and all the other characters are appearing 0 times, right? In for this string also, A is appearing one time, all the other characters are appearing 0 times. So this means they are same. So then I can say that I can break this segment. Then after that, I will restart with my frequency count again. Then from here, if I will check, so obviously A's frequency is 1 and rest of the guys have the frequency as 0. Here also you can see that A's frequency will be 1, rest of the guys will have the frequency as 0. So I can say that again the frequency of both the maps would be same. So again I can break. So I'll mark the count as what? I'll mark the count as nothing but 2 here. Then after that, if you will see the third segment again, so I will restart with my frequency count, and here I will say that A's frequency would be 1, rest of the characters are having frequency as 0. In this segment, A's frequency would be 1 as well for the second string T, and rest of the characters will have the frequency as 0. So again, you can see that both the maps are having the same frequency, so I can mark my count as 3. And this is how I can say that I have broken into 3 segments. Is this much part clear? Please write yes in the chat, guys. Are you clear so far? Please tell me, then we'll move forward, and also please like the video if you are clear with this part, guys. Okay, so far everyone is clear. You can tell me in the chat. I'm waiting for the responses. Okay, now if you will see the second string, let's have a look at the second string, guys. Okay, so if you will see here, let's say you have got like second test case basically. So let's say if you have got what? If you have got something like A, okay, then after that you have got BC, right? Then after that you have the T string, and it is like what? It is like A, and then A, and then what? CB, right? If this is the second string, suppose. So now in this case, if you will see again, I can have map 1 and map 2, and if I will check here, so for this much part you can see that in the first string I will say that, like in the first for the first string I'll say that A's frequency would be 0, rest of the characters would be having the A's frequency will be 1, rest of the characters will have the frequency as 0. For same for the second also, A's frequency will be 1 and rest of the characters will have the frequency as 0. So I can say that the map is same for both, okay, because A is having frequency as 1, rest of the characters are having frequency as 0. A is having frequency as 1, rest of the characters are having frequency as 0. So I can break into this segment, okay. So I'll mark my counter as what? Now I'll mark my count as 1, okay, because this is the first segment that I've broken. Then after that, if I will see here, so what will happen here is A's frequency, again I will restart my map. I will mark my frequencies for the map as 0 for first map as well as second map with respect to first and second string. Now A's frequency would be 1, rest of the characters will have frequency as 0 as of now. Here also A's frequency will be updated as 1, rest of the characters will have frequency as 0. Since both the maps are same right now, so I will say that yes, I can break into this segment. So I'll say that my counter will become what? Nothing but 2, okay. Then after this, what will happen is after this I will move on to the next segment. So when I move on to this particular segment, so you can see that again I will restart my map and A's frequency will be updated to 1, rest of the elements will have the frequency as 0 as of now. Here also what will happen, A's frequency will be 1 and rest of the characters will have the frequency as what? 0. So again you can see that the map is same for all the 26 characters. For all the 26 characters, correspondingly for every character the frequency is the same. So that is why what I will say is that I can break into a third segment. So I'll mark my count as 3. Then after that, what will happen, guys? Again, we will restart with our map. And now what will happen when you are at B? Okay, so now you will update inside the map that B is having frequency as 1 and rest of the characters are having frequency as 0. And when you are in the second string, when you are at C, so you will mark C's frequency as 1 and rest of the characters are having frequency as 0. Now both the maps are same or not? Please tell me, guys. Okay. Are both the maps having same frequency? Because the first map is having B's frequency as 1 and rest of the frequencies as 0, and second map is having C's frequency as 1, rest of the frequencies as 0. Are both the maps same? Yes or no is what I want in the chat. Are both the maps same as of now? Tell me, guys. Are both the maps same? Definitely a big no, because in the first map you are having B with the frequency as 1, rest of the characters with the frequency as 0. In the second map you are having what? C as with the frequency as 1, rest of the characters with the frequency as 0. So map is not same for all the 26 characters. Both the maps are not same. So since they are not same, then you will say that you need to increase the length of this segment. So you will not break here. Okay, then after that you will move to the next guy. The moment you move to the next guy, so C's frequency will be updated to 1 and rest of the guys are having frequency as 0 only. Then when you move here, so B's frequency will be updated to 1 and rest of the guys are having frequency as 0. Now after updating for this particular character, I will check. Now are both the maps same, guys? Please comment in the chat. Now at this point in time, are both the maps same? Please tell me, guys, quickly. Are both the maps same? Yes or no? Yes, both the maps are same. And since both the maps are same, because you can see the for this particular segment, the first map is having B with the frequency as 1, C with the frequency as 1, and rest of the characters with the frequency as 0. The second map is having what? C with the frequency as 1, B with the frequency as 1, and rest of the characters with the frequency as 0. So you will say that since both the maps are same, so you can break into this segment, and you will mark the count as what? 4. So the maximum number of segments that you can break, or maximum number of splits that you can do, is nothing but 4 here. Is that clear to everyone, guys? Please tell me. Okay, so here the output will be 4 for this. You can write clear in the chat, guys. Is everyone clear with this part? You can quickly tell me and then we can proceed further. And if you're clear, please hit the like button if you're clear with this part, guys. Is everyone absolutely clear with this part, guys? Okay, you can write clear, crystal clear in the chat. And then I'll start coding it up. Okay, so for this, what I need is now the thing is that if I want to solve this particular problem, so basically I need to use map. But do you want to like use a map? Like, why do you want to use an inbuilt map? Instead of that, what we can do is we can store the frequencies in form of an array only, right? Because if you see, we only have got 26 characters. If you will see here, so it says that you are given 2 strings, right? And they are non-empty, and you can see that smaller characters are given. So what I can do here is now I can simply start iterate. Like I can simply say that suppose if there is a character A, Okay, how will I represent? So what I can do is I can declare a frequency one array, let's say of 26 size. Okay, and initially I can mark all the frequencies in it as 0. Then I can declare a frequency 2 array of 26 size, and then what I can do is I can mark all the frequencies as what, 0. Now once I have done that, so basically how will I store the frequencies? Because 26 characters are there. So basically what will happen here is the index 0 that is there, it is going to represent the frequency for A. Okay, index 0 will basically try to represent the frequency for the character A in my case. Okay, index 1 I will try to do what? With index 1 I will try to represent the frequency of the character B. But how? Because what will happen is, if a character is like, suppose the character is A, if I subtract the character A from A, what will I get? I will get 0. Okay, then from character B, if I subtract character A, I will get what? 1. Okay, then so on and so forth. If from character Z I subtract the character A, what am I going to get? I'm going to get 25. So what you will do here is basically like, you can say that frequency of 0 you will update. If a character is A, then frequency of 0 will get updated. If suppose a character is Z, then frequency of 25 will get updated. So that is how you can update. Is this part also clear for those who are new into hashing and all? Is this part clear, guys? Right, clear. Now talk about the different ways. Bro, can you please teach me how to understand the problem? I have been telling about the problem only for the past 15 minutes. I have done the same in my solution. Yeah, same approach will be applied. So what I will do here is, now I will declare a frequency one map. Let's say, yeah, F1 map, array, let's say, and then I will mark all the frequencies as what? Let's say 0. Then after that, I will declare a frequency 2 array of 26 size, right, where the indexes will be from 0 to 25. So I will mark all the frequencies as 0. Then I will do what? I will mark my number of segments as 0, count of segments as 0. Then after this, what we will do is we will write the we will take the length of the string. Let's say int n is equal to what? S dot size. Okay, then after this, what you will do is you will iterate in this particular string. So you will say that int I starts from 0, I is lesser than n, then we will do I plus plus. Now what we are going to do is, whatever is the current character, okay, so we are going to increase the frequency for that character in both the strings. So what I will do here is, let's say initially in the F1 string that is there, I will say that whatever is the ith character, I will subtract with it A, and then I will increase its frequency. Then in the second string also, for the second string also, I will do what? T of I minus A, and then I will increase the frequency. Okay. Now once I have done that, so what will I check? I will check if both the maps are same. Okay. So what I will write is, I will write of if function, and I will check maps are same. Let's say I will write a function maps are same. Okay, so in this I will pass the f1 and f2 map, and if both of them are same, if suppose that they return true so far, then in that case what I will do is I will do count plus plus, indicating that I'm going to break it into a segment. Okay, and at the end of the day, whatever is the counter, I will return it. Now in order to check whether maps are same or not, my function would be returning boolean value. So I can write a boolean function here, and let's name it as maps are same. Okay, and then after this we will have the int f1 array, and then you can say we'll have the int f2 array, right? Both the maps will be there, and we will iterate for all the 26 characters. So what I will do here is, I will say that int I starts from 0, I is less than equal to 25, then I plus plus. Okay, and then what we will check is that if there is if the f1 of I is not equal to f2 of I. So if for any corresponding character the frequencies are not same, then overall maps are not same. So you have to return false, that you should not break into segment right now. Otherwise, if maps are same for all the 26 characters starting from 0 till 25th, so you will return what? You will return true. So this is how it will work, and then your code will get done. So is the idea clear to everyone, guys, so far? You can tell me. Now let us try and quickly compile this code as well. Okay, you can tell me, guys, and please hit the like button if you're clear so far. The chart is very slow today. Okay, now let's try and submit this and check if it will get accepted or not. Okay, so you can see that this code gets accepted. So is everyone clear with this, guys? If you are clear, you can directly tell me. Right, is everyone clear with this problem? Kalyan is saying clear. What about others? And please hit the like button, guys, if you're clear. I hope that the whole logic is clear. What I did was, I first of all declared the map, right? And if you want, every time you can refresh your map also. That will also work. I maintain a single map, increase this thing, and then I did this. Yeah, you can do it like that. And also, if you wanted, now, so you can refresh your map every time. After this, now, if this is true, then what you can do is, if you want, like, because the dry run that I have done, for that I have restarted the map again now. So if you want, although that is not compulsory, but if you want, for all the 26 characters, if the maps are same, then after that you can restart. So you can reinitialize the frequencies of the map as 0, because that is how I was doing in the dry run. So that's why let's do this. But also, this is not a necessity, but this will still work. Okay, so is that clear? Let me quickly generate the link for this code, and then we will move on to the next problem as well. Yeah, if you want to refresh, like, it is not necessary to refresh, but the reason why I have refreshed, Ganesh, now, because I was telling about the approach from the very basic level. Okay, for any beginner also, I was telling about the approach from the basic level. So that is why I have told, if you want to refresh your map, you can, because the way that I have done the dry run, in that dry run, every time I was trying to refresh the map, and refreshing the map would not take much time now, because there are only 26 characters, so it's kind of a constant operation only. Okay, if map 1 equal to map 2, why did this not work? Why did this not work? I'm not very sure. It depends from language to language, but ideally the thing is that you can iterate and check for every place. Now, if you wanted to check like that, then in that case, I think you should, maybe if you use vector, then that would be possible. Okay, so let me quickly share this code link here. Okay, so yeah, can we move on to the next problem, guys? You can write next in the chat. Okay, guys, please tell me if we can move on to the next problem. Then I will start with the next problem now. Okay, so yeah, let's start with the next problem now, guys. Okay, everyone was clear with the previous one, na, guys? Very good, very good. So yeah, if you will see this particular problem now, I will say that this problem was a little bit tough for me also. The reason for that is not because it is tough to implement. The thing is that initially I was thinking a lot in this problem. Okay, but this is a very simple problem if you have to solve it. uh, I used unordered map. Like, why do you want to use map now? Basically, Dhruv, the thing is, if you want to, like, see, maybe it might have worked using unordered map, maybe it might have not. But the thing is that whenever you are in an interview, no, so interviewer will expect that if something can be done very easily, so why do you want to declare a map implementation and then do it now? Because that will unnecessarily increase the complexity of your code. But was able to solve question 4. For me, this was hard. Yeah, it was a little bit on the harder side, because it was based on observation, and this question basically is mostly based on dry run. The more you do dry run, the more you hit and try, then you will get it. Okay, so let's understand this problem very quickly. It says that you have to minimize the array. Okay, so the problem name is what? Minimize the array. Minimize the array. Okay, now in this particular problem, you have been given an array of positive integers. Suppose that you have got an array, right? If you have got an array, so you have got an array of positive integers, and what you have to do is you have to minimize the array. Okay, so what we are doing is, if you will understand, so suppose there is an array, right? Suppose this is an array. Now, what you will do is, at in one step, what you can do is you can choose two consecutive elements. Suppose this is the index I, and this is the index I plus 1. So what you can basically do in this particular array is, now you can, like, you will have, let's say you have the ith element and you have the I plus 1th element, basically two consecutive, two neighboring elements. So if you have these two elements now, so instead of this, you can do what? You can either replace this with a of I modulus a of I plus 1. Okay, so instead of these two elements, you can replace it with a single element like this, or you can replace with a single element like a of I plus 1 modulo with a of I. Okay, for example, suppose there was an array like suppose there was this array, okay, and in this array you had 3 and you had 5 here, suppose. Okay, then what you could have done is you could have taken these two elements, okay, and instead of these two elements, either you would have replaced it with what, 3 mod 5, let's say that is 3, or you could have replaced it with what, you could have replaced it with 5 mod 3, that is 2. So either you could have put like instead of these two elements, either you could have replaced it with 3, or you could have replaced this with 2. So that depends. Is that clear, guys? Count of consecutive pairs which are same. Okay, so Arani is saying count of consecutive. Okay, like there can be multiple approaches. Is this much part clear to everyone, guys? What we are doing in one operation, basically you take two adjacent elements and you will replace it with the mod of the first element with the second one, or you will replace it with the value of the mod of second element with the first one. Okay, is the problem statement clear? And when you will do this, so the array size will reduce. But what will happen if suppose a scenario like this is there? Okay, suppose guys that if you keep on reducing the array, suppose there was an array, right? Now if you apply some operations, after some operations, right, what happens is if the array looks like this, okay, after certain operations, suppose that now the array looks like what, now at the end of the day, if the array has got only two elements and both the elements are 0, then can you reduce the array more, guys? Tell me, can you reduce the array more if both the elements are 0? After, like suppose that you had a lot of elements in the original array, you kept on doing some operations, and at the end of the day, right now at this moment you have got 0 0. Now can you perform this operation? Can you perform the operation of a of like can you perform the operation of either a of I modulus a of I plus 1, or can you perform the operation of a of I plus 1 modulo a of I? Yes or no? Please comment in the chat. No, we cannot, because modulo by 0 is not allowed now. Actually, modulo by 0 is not allowed because division by 0 is not allowed. Okay. No, it will be undefined. Yeah. Division by 0 is actually not allowed. That is why. Makes sense, guys? Because division by 0 is not allowed. If you will see this example, suppose that if you will see the first example, let's have a look at the first example first of all. Suppose if I had the array as 1, 1, then I had 2, then I had got 3. Okay, if I had this particular array, then after this, let's say if this array was there, so let's say if you pick these two elements, okay, and then what will happen is if you pick these two elements, then you will have one is already there. Then you, like suppose what you can do is you can do 1 modulo 2. So 1 modulo 2 will give me 1. So here I will place 1. Then after that 3 will be here. Okay, so now the array looks like this. Then after that, what I can do is again I can take these two elements, suppose, and now what I can do is I can do 1 modulo 3, and this will give me 1 again. So now what will happen? The array will look like 1 1. Now after that, again if I have taken an element, so 1 modulo 1 will be what, 0. So instead of these two elements, I will replace it with a single element 0. So now finally the size of the array is how much? 1 only now. So only one element is remaining, and this is the minimum possible that we can get now. Is this part clear? Please write clear in the chat, guys. Is this part clear? Originally this was the array, original, and at the end of the day, this is how the array looks like. Make sense, guys? Yes or no? If yes, then you can hit the like button, guys. Everyone, please be very energetic. Okay, this is the case. Now if you will see the second test case, suppose, okay, so if I will have a look at the second test case, so let's say you have got what, you have got 2, then you have got 2, then you have got 2, and then you have got 2 again. Okay, if you have got this particular array, suppose, now what will happen here is if you have got this particular array, right, so what you can do is, let's say you pick these two elements, right, then after this what will happen, you will have 0, okay, then 2 and 2, because 2 modulo 2 is what, guys, 0 na? So you will replace with this with 0. Then after that, if you will see, so what they are saying is, if you do this, right, and then after that, what you do is, let's say you pick these two elements, then this will be what, 0, and then again 0, and now this is the case, and finally you can say that the size is 2 here. So the minimum size is 2 here. Is that clear, guys? Minimum size is 2 here. Does this make sense? Okay. Clear, guys? You can just let me know, and then we will proceed further. Now, when you have been given this thing now, so one thing is very important, that whatever array has been given to you, you can do what, like if suppose that any array has been given, how, like what observation can I have? So what I can do is, suppose that the array has been given, right? So when will I get, like when do we get zeros, guys? When am I getting zeros, right? So basically ultimately the thing is that if you will keep a track of the minimum element now, then solving this problem will become a little bit easier. Although there might be multiple approaches, I have not tried them, but one of my observations is that if you keep a track of the minimum element, then you will be able to figure out that what is going to be the answer. Why 2 modulo 2? Instead we can take 0 mod 2. No, 0 mod 2. No. 0 mod 2 is not positive. Now you can see here that given an array of positive integer, you are performed any operation, possibly 0, replace any two positive integers with this thing and this thing. Okay. So this thing, thus after each operation, the length of the array reduces by 1. Basically, the thing is, if you would have done that, the thing that you're suggesting, if you would have done that now, so you had 0, 2 and 2. If you will take this and this, so if you will do 0 modulo 2, what will it give? It will give you 0 again, I guess. Like what is 0 modulo 2? Let me just cross check, but I think it is 0 only. 0 mod 2, just checking for uh, yeah, 0 mod 2 is 0 only. Then this would have been 0, so this would have been 0 and then 2, then again 0 mod 2. I guess that, yeah, you need positive elements in the array. Actually the thing, no, that cannot be done, I guess. Why? Because is it given in the question? 0 is not positive. Yeah, if you had this and this, right? So 2 and 2 was there. Okay, let's just check this. Thus the array becomes this, and then after that 2 modulo 2 and 2 with 0, so array becomes this, and after that this is the minimum length possible. Okay, so I guess, like, yeah, so basically whenever you are doing the modulo operation, so the elements need to be positive. Okay, what you need to do is, whenever you are doing the modulo, so basically both the elements should be positive. That is the main scenario. Kind of, that is the main scenario. Whenever you are doing the modulo, so kind of you can say both the elements need to be 0. Sorry, positive. That is why. Okay. Yeah, if you can take 0, then one element in the end in any case. Yeah, if 0 will be allowed na, then the answer will always be 1. If 0 is allowed na, if 0 mod something is allowed, then the answer will always be 1, because in that case at the end of the day you will always have one element remaining only. Okay, so that is why this case is not allowed. Okay, the reason is because, like, in that case every time the answer will be 1 only. So then there will be no point of making this question, no? Okay, so if you will see here, the thing is that if I keep a track of the minimum element, right, so based on the minimum element I can make my decision. How? Basically what I can do is, let's say if I had got suppose there was this array, right? If I had got 1, okay, then after that I had got 3, then I had got 2, and then I had got 1. Suppose this array is given to me, right? If suppose that this kind of array has been given to me, so in this particular array the minimum element is what, guys? The minimum element is 1. Okay, now since the minimum element is 1, then I will do what? I will basically maintain the count of the minimum element. Okay, what you can do is you can maintain a count of the minimum element also. First of all, store the minimum element and then maintain a counter. Okay, suppose if the array look like what? Suppose let's take one example, 1 2 3 4. Okay, suppose this is one example that I'm taking. Now here, like if you will see this kind of an example, guys, so what will happen here? If you will see, the minimum element will be what? 1. And what is the count of the minimum element here? Count of the minimum element is also 1. Okay, because it is occurring one time. So if you will see here, what I can do is, if I take if I take this and this guy, then this would get replaced with 1. Okay, then you will have 2 and then 1, right? Suppose this is the case. Then after that, again you take these two elements, this would be replaced with what? Like you can replace it with 1, then you'll have 1, then you have these elements, right? Then after that, what you do is you take these two and then you will get 0. So basically, if the minimum element is occurring one time, then always the size would be 1, then always the answer will be 1. Are you getting my point? If suppose that the minimum element is occurring only one time, if the minimum element of the array is occurring only one time, then the answer would be 1. Is that clear, guys? Yes or no? Please tell me. Okay, if the minimum element inside this array is occurring only one time, please check my approach. What is your approach, Monu? I can't see your approach in the chat. right? So yeah, is this part clear? Please write, is it best or not? I haven't, like, I can't see your code actually, right? So yeah, basically guys, are you clear with my point that if you will see here, right, basically how can we prove this fact, like basically how did I prove? So I did a dry run on a lot of test cases, right? I was doing, like, basically what I did was I thought about a lot of test cases, and then I was thinking what can be done here, what can be done here, like what will be the answer. So if you will see, suppose that if you have got something like 2 3 4 5, like suppose that you have got something like, let's say this, okay, if you have got something like this, then again the minimum element is what, let's say 2 here, and the count of the minimum element is what guys, 1. It is occurring only one time, right? Now what will happen, now what will happen here is, if suppose that you choose this and this element, okay, suppose, because you will always be playing an optimal game, suppose if you choose these two elements, then what will happen, now you will have the array as 2, and then let's say what can I do, I can place 3 here only, and then 4, right? Then after this, you take these two elements, and then you can replace it with what, let's say with the guy as, let's say 3, okay, and then after that you will have 2 here. And then after this, at the end of the day, when you will again replace, so let's say if you want to replace, so you can do modulo with 2 modulo 3 or 3 modulo 2, whatever you like. Let's say if I'll do 3 modulo 2, then like, or let's say I will do 2 like, let's say if I will do what, 2 modulo 3, then I will get what, 2. So you can see that I'm getting only one single guy at the end, no? Does that make sense, guys? You can try it on a lot of test cases, but still this works. Is that clear, guys? Please tell me. Can I expect that this part is clear? If the minimum element is occurring one time, then the answer will always be 1. Is that clear? You have to tell me, guys. Is this idea clear? I am waiting for your responses in the chat. Okay. So what I'm saying here is, firstly, in order to write the logic, if you will see, firstly, let's have a look at the minimum element. So initially, I will mark the minimum as what? Int maximum. Okay. And then after that, what I will do is I'll iterate in this array. So let's say int I starts from 0, I is lesser than n, then I'll do an I plus plus. As if we take the modulo of two numbers, then modulo will always be the number itself. Yeah, basically, I don't want to go into very deep mathematics, but what Bankai is saying might is also possibly clear. You, like, you, if you want, you can prove this fact, but I am, as I said now, I am proving this method with the hit and trial basis, right? By thinking about a lot of test cases. You can obviously give a mathematical reason behind it also. That is also fine. But I did a dry run on 4 or 5 test cases, and that is how I 4 or 5 different random test cases, and that is how I was eventually able to figure out this particular concept that I'm saying here. Okay. So what I will do is I will mark my count of the minimum element as what, initially let's say 0, and then after that, like what I can do is I can say that if the minimum element is greater than the ith element of the array, right? So in that case, the minimum element will be what? ARR of I. So firstly, I'm storing the minimum element. Okay, once I've stored the minimum element, then I can iterate again inside this array. So I starts from 0, I is less than n, then I'll do an I plus plus here. Now after this, what I will do is I will check. What will I check? I will check that if the ith element is equal to the minimum element, although I can use function to count the number of times the minimum element is occurring, but I am again iterating for it. Okay, so in that case, like whatever number of times the minimum element is present, I will get its counter. Now if my counter is what, guys, if suppose that, I understand that, I completely understand that, that is not a problem. Okay, I am just telling one thing here, that, like, basically I'm trying to solve this problem segment by segment, the way that I have thought. I am not neglecting the fact that like through in other cases also the answer can be 1, but I am just right now I am just trying to do a dry run and then tell you uh, that why like whenever the count, like, whenever the minimum element is occurring one time only now, then what will happen. Otherwise, what will be the scenarios, that also I will try to cover. Okay, so if you will see here, then in that case I can simply return 1 if the count is 1. Okay, now after this particular thing is done, then you need to check. Okay, now after this, suppose that you have got what, let's say you have got something like let's say 2. Okay, let's take one example here. Suppose you have got 2 2, and then you have got what, let's say something like 3 and then 3. Okay, suppose you have got this particular test case here. Okay, then what is going to be the answer here? Let's try and think about it, guys. Okay, or let's take a better test case here. Suppose that you have got 7 here, then you have got what, 3 here, then you have got 3 here. Okay, then you have got 7 here. Suppose you have got 7 here as well. Okay, if you have got this kind of an array. Okay, so here the thing is that minimum element is what, 3, and count of the minimum element is what, guys? 2. It is occurring 2 times, right? Now if I have to solve this particular test case, there can be multiple ways, but one of the ways that I can think of is that if these two elements are there, right, then what will happen here is I will mark this as 7, then 3, and then I can put 3 here again, and then 7. Okay, now after that, again, if I use this and this guy, right, so like basically what I did was, now I did 3 modulo with 7, so I will get 3 again. Okay, so this is one advantage that I'm using here. Now after this, if you take this and this, so what will be the scenario here, guys? Now again you will put 3 here, and then 3 here, and then 3, right, because here you will get this 3. Now after that, what you can do is you can take this and this element. Okay, then what will happen, guys? You will have 3. Okay, and then what you will have is let's say you will have 3 here again, right? Now you can take these two elements, and then you will get what, 0. So basically only one single element is there. Is that clear, guys? Although you can take multiple different test cases, but if you will see here, for this kind of test case, the answer comes out to be 1. Here also the size comes out to be 1 for this kind of test case. Okay, for this kind of test case also the answer comes out to be 1. Now like obviously this question is kind of very exhausting in nature, because you have to do a lot of dry run. If you are like, see, if you are mathematically very strong, then you might be able to solve it very quickly. But if you are a hard work, like if you are dependent on hard work and dry run like me, then you have to do something like this only to be very sure. 7 modulo 3 is 1. I did 3 modulo 7, no? Rohit Garg, I did 3 modulo 7. So I did it correctly, no? Like you can do anything that is allowed, no? Yeah, so you can do anything. 3 modulo 7, 7 modulo 3, both are fine. So please hit the like button so far, guys, if you are comfortable. Okay. Yes. So now what has happened is, now 3 modulo 7 is what, 3 only, right? Okay. So yeah, I guess this is fine. So the thing is, guys, that I'm trying to tell you that if you will observe one thing, one thing that is very important is how many times the minimum element was present here. Like if you will see here now, the thing is that in this particular scenario, a multiple of minimum element was present. If the minimum element was 3, its multiple was present here. Okay, right, its multiple was present. If you will see here, let's say what you can take is, let's say if you will take something like this. Okay, let's say if I'll take a test case like suppose that if what happens is, if a test case like this is there, let's say if I have got something like let's say 7 is there. Okay, then I have got 5 here, then I have got what, let's say I have got 7 here. No, let's not take 7, let's take 14 or something, right? Yeah, let's take 14 itself. Let's say after that I have got what, let's say I have got something like 8 here, suppose. Okay, suppose these are the elements that I have got. Now what will happen here is, guys, let's say what I can do here is if these elements are given to me, right, what will happen here? If these two elements are there, then 7 is there. Okay, then 5 and 14. So what can I do? I can do anything, but let's say, yeah, you can have 5 here, and then you can have what, 8 here. Okay, and then after that, let's say after that, what you can do is, if you have this and this, right, then you will have 5 here and then 8 here. Then after that, you will have what, single element as 5 only. Right. So this is how you can get the size as one also. Right. So is this part clear to everyone, guys? Yes or no? Please, like, tell me. So I think if you will check, right? If you will check, okay. Yeah, so basically the thing is that if there is at least one single element, basically when are you having problem, understand one thing, when the size is when what is the problem for you, understand this thing. What is the problem arises when you have multiples, okay? Because if you see, yeah, if you see, suppose that the minimum element is 2, okay, and now you have got what, you have got 4, 6, 8, something of this kind, okay? When you have got the multiples, right, when you have got the multiples of the minimum element, then don't you think that you have a problem now? Agree, guys? When you have got the multiples of minimum element, then you have a little bit of problem in solving it. Are you getting my point? Let's suppose you have got two here and all these things. If the thing is that whenever you have got multiples, whenever you have got multiples of the minimum element, then you have a problem. Yeah. So if you will see here, guys, what I'm telling is whenever you have got multiples of the minimum element, then you have a problem. If you will see here, suppose if I will solve this and this, understand this thing very clearly. If suppose that this was the only test case, right? So far, now what you will do, suppose that if you apply the operations of between this and this, so this will become what, 2, then you will have 6 and 8. Okay. Then after that, again, if you will do the modulo operation, so what will you get? Let's say you do here also. Right. So what will you get here? 2 modulo 6 will be 2 only, I think. Okay. So let's say 2 and then 8. I think the answer for this case would be 1 only. Right. Let me think. If you have got 2, 4, 6, 8, then the answer for this case will be 2 only. Correct. Right. Otherwise, like, is that so? Let me check. If you have got 2, 4, suppose you take 2 and 4, then you will have 2 only out of that. Then 2 and 6, so you will have 2. Then 2 and 8, again you can have 2, right? I think that will work. Let's check with either this or this. Okay, yeah, so I guess the answer will be 1 only, no? Okay, let's say if I will write a test case which is a bit complicated. Let's say I will put what I will do here is, suppose I have got something like 14 here. Let's take 14. Okay, then after that I have got something like 7 here. Then I've got what, I've got something like 14 here. Okay, then I've got what, let's say I've got something like 21 here, suppose, if I've got this thing. Okay, now whenever you will take the modulo, so you will see that you will have a bit of difficulty, because if you take the modulus here, suppose, you'll get what, you will get 7, then this is 7 and this is 14. Okay, now after that, when you do the, when you take again, so what will happen, you take these two guys, then you'll get what, 0 and 7. Now you cannot do any modulo, so the size will be 2. Okay, so when does the problem arise, whenever you have the multiples, right? Whenever you have the multiples of the minimum element, right? Whenever you have inside the array, whenever you have multiples of the minimum element now, then the task becomes difficult. Is that clear to everyone or not, guys? Right, whenever inside the array you have got what, you have got the multiples of the minimum element, then the size increases. Are you clear with this part, guys? Because in that case now, you will have several zeros somewhere or the other. You will get, like, you will get the divisibility part, because since they are multiple, so somewhere you will get zeros, right? Is that clear, guys? Yeah, we don't want to make the remainder as 0. So when will you get the remainder as 0? When you have got multiples of the minimum number. Now inside the array, if there are multiples of the minimum number, that is when you will have a problem. Okay, you are saying that what you could have done is 7 modulo 14 would have been 7, but that would still, like, if you would have done that, still, okay, yeah, then it would have worked, yeah. So what you are saying is something of this kind. Okay, let's think about it. If you want, now let's say I will write something like this only. See, the thing is that if you have got this thing only, right? If you have got this only, what will happen here? You will take these two, then what will happen? Then you can see here that basically you will have 0 and then 7. Na? So basically the problem is when the minimum element like is there, okay, and they are kind of like when minimum element is occurring, suppose more than 3 times, then can I say this? No, you can't, because still you might be able to reduce. But the thing is that if you do 7, if you had 7 and 7 here, right, then you got 0, and because of this 0, now the size is 2 here. So what I'm trying to say is that if you have the array, right, if you have the norm, if you have any, if you have the array, right, and inside this array, suppose you have the minimum element here, and rest of the elements are occurring here and here. Okay, so if you have at least one element that is not divisible by what? If you have at least one element that is not divisible by the minimum element, then the size will always be 1. Okay, because if you see here, suppose if I had what, like as I said, if I had something like 2 was there, okay, then 8 was there, then 10 was there, okay, then 14 was there, then 4 was there, then 8 was there, suppose, and suppose you had 9 as well. Okay, then you had what, let's say 6. If you had this kind of a scenario now, so if there is at least one element now, because see, if there are multiples of 2, then I have a problem, right? But if there is at least one element that is not a multiple of 2, then the answer will always be 1. You can be very assured, because if you see this kind of a scenario now, that was given in the sample also, then you will have a problem of 0 0. So if at least one element is there that is not divisible by 2, then in that case you will always get non-zero. Okay, and that will help you to get your job done. Is that clear, guys? Please tell me, is that idea clear? If you have at least one element that is not divisible by the minimum element, then you will have your answer as 1. Is that clear, guys? Or not? So what you can check is, basically, if you want, you can iterate throughout the array. I starts from 0, I is lesser than n, and I plus plus, and then you can check inside the array that if there is any element whose modulo with the minimum element, okay, gives me the remainder as what, like modulo with minimum element gives me the remainder as greater than 0. Okay, then in that case you will return 1, because in that case somehow or the other you will be able to get only one element at the end. Okay, you can try it on a lot of cases. Otherwise, what will be the answer? So otherwise, you can see always what is the worst case. Like in the worst case, what will happen in the worst cases, right? If you had this array, let's take this array, guys. What will happen for this array? Tell me. Suppose you have got this array, then you will do what? Let's say you will pick these two guys, and these two guys. What will you get here? Can you guys tell me? This thing I understood, very good. So yeah, you can see you will get 0 here because of that operation that you would have applied. Then you would have got what, this and this, and then you will apply on this. So what will you get? You will get 0 0 and then 2 2. Then you'll apply on these two, so you'll get what, 0 0 0. So at 3, the size of the array would be 3 here, right? Now if suppose that I had what, like, so basically you might say that if the size of the array is 6, then the answer would be n by 2. Okay, but suppose if you had what, like if you had got 2 2 2 2 and 2, suppose this was the scenario. Okay, n is equal to 5 here. Now what will be the size of the array finally? If you see, these two elements will replace with 0, these two elements will replace with 0, and then here you'll have 2. So the final array is having how much size as 3. So basically you need to say that the answer will be n plus 1 by 2. Is that clear, guys? Actually, the answer in all the other cases would be n plus 1 by 2. Is that clear? Or, like, to be very honest, what you can say is, see, basically the thing is, suppose if you had got something like this, I'll tell you one more thing. Suppose if you had 2 2 2 2, okay, and then what you had was, if you had 2 2 2 2, and then after that, suppose if you had got these elements, and after that if you had anything, like let's say you had 7 8 9 10, suppose these were the elements that you had. Okay, now if these were the elements, what will happen here? If these were the elements, okay, so what will happen in this scenario? You can say that these two elements will club together and you will have 2 here. Correct, guys? Right, because 2 modulo 7 will give me what? 2 modulo 7 will give me 2. Okay, then after that, when I will take these two elements, what will I get? I'll get nothing but 2 again. Then I take these two elements, again I can get 2, because 2 modulo 9 will be what? 2. Then after that, when I take these two elements also, then I'll get what? I'll get 2 only. So at the end of the day, you can see that from this whole segment that is there now, this whole other segment that is there, I'm getting what? I'm getting 2 only, right? So, like, sorry, from this whole segment, actually, this whole segment, all the other segment, the rest of the segment actually got neutralized. Okay, all the other elements got neutralized, and at the end, only the minimum element remained. I can keep on solving the remainder part in such a way that the minimum element is only left. So basically, what will happen? The higher elements can get replaced. Okay, the higher elements, I can eliminate the higher elements. Okay, so that is why what I can say is, at the end of the day, the answer will be, I can do what I can write. I can think about the logic in such a way that always the minimum element will only remain. So whatever is the minimum element, the final answer will be the count of the minimum element divided by 2 plus 1 divided by 2. Is that clear, guys? Please write yes or no in the chat. Is that clear? Right. If you are clear, you can tell me. Okay, so this person is asking that here this is the scenario, but the thing is now that, like, the minimum element, okay, you are asking that here the count is 1. Okay, you're asking that there is at least one element that is, but actually the thing is, the minimum element is occurring more time now. Minimum element should occur one time. Kalyan, in that case, the minimum element should occur only one time, but here the minimum element is occurring more than one time now. Understood, Kalyan? That is why I had written this thing now. If the minimum element is occurring one time, but here the minimum element was not occurring one time now. Makes sense? Okay, so basically what I'm trying to say is, let's say, but let me think about it. Let's say if you had 2 2 2 2 only, and then you had got 7, suppose. Okay, right. If you had got this thing, then if you replace, okay, so this will be what? This will be like, basically I'm trying to, आज out of city था तो नहीं दे पाया, no problem. Like, basically, guys, I'm taking some time so that I can explain this properly, so that you are much more clear. But as I said, this depends on dry run. This is a lengthy question, by the way. So let's say if I had to solve this, right? So getting the same element would be tough. If I get what? If I get 1 here, suppose, right? Still, it would depend on the, like, okay, if there is at least one element that is not divisible, okay, so then I will get 2 2. Now what will happen is, now I will solve it. So this is the case. Okay, so when I will solve this, because I'm writing a lot of test cases, I'm myself getting a little bit stuck. Yeah, so you can see here, then what can I do? I can again get 1 here from here, then I can get 2. Yeah, so now I will solve, so I get 0. Yeah, so if there is at least one element that is not divisible, na, so I will be able to manipulate. Yeah. The thing is that if you give me any number of 2s, if you give me a lot of 2s, guys, even if I have a lot of 2s, still in that case, I will be able to digest. Suppose if I have got this thing, okay, then I've got this thing, and then I've got this thing. Suppose, guys, okay. Now what I will do here is, I will take this guy and this guy. I'll get what? I'll get 1 here. Then after that, I'll take this guy with this guy. So I'll get what? 1 here. So after this, this array will be what? 2 2 2 and then 1. Okay, then after this, I will take this guy and this guy. I'll get 1. Then I'll take this guy, this guy. I'll get 1 again. Then I'll take this guy, this guy. So I'll get 1 again. So ultimately, you can see that I'm getting able to get this thing. So I think the answer for this case will be 1 only. No, am I correct? You can tell me. Yeah, if there is at least one element na, that is not divisible by the minimum element, then the answer will be 1. That is very much clear. Is that clear? Otherwise, in all the other cases, the thing is, if you have a scenario like 2 2 2 2, like this, then the answer will be count of the minimum element plus 1 by 2. It is 2. Basically, why for this case you are saying 2? When I will solve this, right? So I'll get 1 from, like, see, when I will solve this and this, so I'll get what? Let's say if I solve it like that, so I'll get 1 here. The moment I get 1, so again, I can do 1 modulo 2 to get 1 again from here. No, then from with this and this guy I'll get 1, then with this and this guy I'll get 1. So I think the answer will be finally 1. If there is at least one element that is not divisible by the minimum, then the answer will be 1. Yeah, that remains true only. But otherwise, in the other cases, what can I return? I can return the answer as count of the minimum element plus 1 divided by 2. So these are the scenarios. You can try and test them. Okay, Yeah, so it works. Let's try and submit this. I hope it will get accepted. Yeah, it does get accepted. So is everyone clear with the dry run part? Basically, this question was based on a lot of dry runs. Okay. If you're confident about your approach, then like basically if you're confident about your dry run, then this was easy. Otherwise, it was a little tough in case of thought process. So you can hit the like button, guys, if you're clear so far. Okay. You all have understood so far, guys. Please tell me quickly. And please do hit the like button and then we'll proceed further. Okay. Sir, one quick revision. Actually, Bankai, like basically, yeah, I will just tell you quickly if you want. Okay, so the thing is, Bankai, that if the minimum element is occurring only one time, so now we have run so many dry runs now that you know that if minimum element is occurring one time only, then somehow or the other you will be able to try and solve it in such a way that you'll get only one element. Okay. Otherwise, you have seen many cases when whenever there is an element. Okay, if there is any element in the array which is not divisible by the minimum element, then in that case you can always reduce the array size to 1. Otherwise, if you have otherwise the problem will arise whenever you have multiple minimum elements. Whenever you have multiple minimum elements, so in that case there will be a lot of zeros that will get generated. So in that case the answer will be what? The answer would be count of count of minimum element plus 1 by 2. Okay. Yeah, just to summarize, like this is what I'm telling, but I hope after a lot of dry runs now the ideology is clear that how we had to think about it, right? So please write clear in the chat, guys, and then I will move forward to the third problem of the contest. Okay, I hope that everyone is very much clear with the logic so far. Okay, the second problem was a good one. Please hit the like button, guys, and then I'll proceed further. I hope that audio and everything is fine. Okay, I think my Bluetooth is still connected, so that is why I'm not getting the noise. Everyone is very much clear with the logic. All right. So yeah, let's move forward. Let's move forward now, and let's solve some more problems. Okay. So yes, now let's have a look at the problem. Let's say maximum cost of I think this problem is quite easy. Maximize the cost. Okay, what was your approach? Like, how many of you were able to solve maximize the code? Like, I think someone was saying that he was able to solve the fourth problem. When the minimum element is 1, see, when the minimum element is 1, then the answer will be 2. It depends on test case to test case, but it depends on the other elements, how the other elements are behaving, no? If you want, you can write, like, see, in if you will think like that, then your if else cases will increase a lot, no? If you will think about the minimum element being 1, 2, or something like that, so then your if else cases will increase a lot. So I only thought about the minimum element, not if the minimum element is 1, right? I only thought about what if I have the minimum element with me and I have the count of the minimum element, how will the behavior be? Okay. Right. Yeah. So if you will see here, maximize the cost is the name of this problem. So how many of you were able to solve this problem, guys? Please tell me. Okay. Maximize the cost. So basically the problem, let's see what the problem says here. Okay, the problem says that Geek has an array of integers of n size. Okay, so basically this guy Geek who is there, he has got an array with himself. This guy Geek has got an array with himself, and the ith element denotes the price of the ith gift. Okay, so a of I denotes what? A of I denotes the price of the ith gift. Price of the ith gift. Okay, he wants to buy exactly x gifts for himself and wants to maximize the total cost of his gifts. Okay, so he wants to buy how much gifts? He wants to buy exactly x gifts. Okay, like he wants to buy x gifts, and he wants to do what? He wants to maximize, let's check this. So he wants to do what? He wants to he wants to maximize the total cost. So the cost of the like the total cost of the gift chosen by him is equal to the minimum absolute difference between the prices of the gift. Okay, so is the minimum absolute difference between the prices of any two gifts. Okay, so here they are saying that, okay, so basically whenever you have given an array, so you will take the like basically the total cost of the gifts chosen by him is equal to the minimum absolute difference between the prices of any two gifts. So suppose if you had got what, if you have got 7, 15, okay, then what, 2, and then what, 4, and then what, 9. Okay, if you have got this array, suppose, right, so here the cost, if this is the scenario, okay, suppose this is the scenario and he has taken the cost as what, so he wants to choose what, he wants to maximize the total cost of his gifts. Okay, he wants to choose exactly k gifts and wants to maximize the total. Okay, so the total is given equal to the minimum cost. Okay, okay, okay. So the maximum cost for buying two gifts will be 10. Okay. Okay. So if you will see here, the thing is that if I choose my cost as what? Let's say if I choose my cost as something like, let's say if these are the costs, right? So if these are the cost, what I do is, if I choose the cost as 50, okay. So basically, if I choose if I choose my cost as suppose 50, right? Then suppose if I have got these two elements, guys, okay. So if I see the absolute difference between this element and this element, it will be 7. So is this cost greater equal, like is this difference greater than my cost? No. So like let's say what happened, let's say if you have got this test case, right? So next question is black tree. Yeah, I understand that, but still we are doing this one first of all. इसमें तो साफ साफ greedy लग रहा. Yeah, but I think it can be optimized using binary search, because here it is asking you to do what? Geek will buy gifts with prices. The total cost of these gifts will be 6. Okay. So you have to maximize the total cost. The total cost is equal to minimum absolute difference. Okay. So you have to maximize the cost. Okay. That is fine. Now, what is cost for you? Okay. So yeah, if you will see, suppose like if this is the scenario, okay. Basically, the cost is what? Let me just check this. So basically, the total cost of the gifts chosen by him is equal to the minimum absolute difference between any two prices. Okay. So if it is minimum, suppose that if I choose the cost as what, guys? If I choose the cost as, suppose what I do is, if I choose the cost as something like, let's say 2. So here the adjacent is 7. And suppose he wants to buy how many toys? I guess he wants to buy X number of toys, no? So X value is 3 here. So he wants to buy at least 3 toys. Like he wants to buy exactly 3 toys, I guess, right? So then in that case, if I choose, like if I have to choose the cost, so if the cost suppose was 2, and if I check between the adjacent elements, so if I check from here to here, right, so what can happen, like if suppose that I would have kept the cost as what, let's say I would have kept the cost as suppose 1, okay, or let's say if I would have kept the cost as, yeah, let's say if I would have kept the cost as 1, okay, then I will check that right now is the absolute difference of this greater than the cost? Yes. So this means that I can let's say I will try to buy this, so I'll say that yes, I will do a +1. Then after that, again this is bigger, so I'll do a +1, I can buy, then again +1, again +1, because the absolute differences are greater than my this cost. Okay, so here I will get the count as 4. If I get the count as 4, so I will say that let's try and increase the counter. So let's say what I will do is, if I will try to say that let's keep the cost as 2, if I keep my cost as 2, then how many of them will satisfy? Again, all 4 will get satisfied, because this will get satisfied, right? That is plus 1, then here also plus 1, then here also plus 1, here also you can say plus 1, right? Because obviously all the absolute differences that you will see here, they are greater equal to 2, the greater equal to the cost that I have chosen. So here I will be able to buy 4 toys. So I will try to increase again, and then what I will do is, let's say if I keep the cost as 3 here, okay, if I keep the cost as 3 here, then what will happen, between these two adjacent elements, this is what, if you will check here, so I can do a plus 1 here, then I can do a plus 1 here, then this will not be done because the absolute difference is not greater than the cost, and then I will choose this, so absolute difference is greater, so I can do a plus 1 here. So you can see that when the cost is 3, so I am able to buy exactly 3 toys. Are you clear with this part, guys? Right. So I guess the answer is what, 6. Okay, why is the answer 6? Because, okay, so when the cost is 3, then I also am able to get, when the cost will be 4, then also I'll be able to get it. Yeah, sort करने के बाद, like, do I need to sort the array? Yeah, I can sort the array now. Yes, basically why I can sort the array, because otherwise, yeah, so the thing is now, I want, like, see, I want, like, the total cost of the gifts is minimum absolute difference. So basically you can sort the input. Why you can sort the input? Because suppose there is an element like 15 here, and you have, let's say you have got 17 here, okay, after sorting, what will happen in this case is, now when you will write this array like this, 15 comma 17, then when you will see the adjacent difference now, so this will be basically 2 only, so that will be very less. Whereas if you will keep, if the element was 1 here, right, so if you take the adjacent absolute difference of 15 and 1, so this will come out to be 14, which is very very high. Okay, so that is why it is very important that you sort the array, so that what happens is, the elements, like, so that the bigger elements are closer to each other, then the absolute difference will drop. Is that clear, guys? So yeah, that is why sorting would be important. Does that make sense, guys? Yes or no? You can tell me. Okay, so yes, if you will see here, what I need to do is, I can apply bind search, because if you will see this kind of problem, so basically the problems where what you have to do is, whenever there is a problem, okay, understand this, like, you have to understand this trick. Basically, whenever you have to do what, you have to maximize the minimum, okay, or what you have to do is, you have to minimize the maximum. Then we use binary search. Do you know about this, guys? For example, one of the problems that you can try out is minimum allocation of books. Right. Okay. So what we can do here is, suppose, like, firstly, I will have my, like, I will be getting my array. So I can say that my lowest will be what? 0. And then my highest range will be what? Let me just check the constraint. So constraint is 10 to the power 6. Okay. So let me update this as 10 to the power 6. So 1, 2, 3, 4, 5, 6. Okay. So this is my lowest and highest range. And I have to, like, lowest range for the cost and highest range for the cost. Suppose then I can do what? Like, let's say I can update my answer initially as 0. And then we will say that I can apply a bind search while low is, also I need to sort the array. So let's say I will sort the array dot begin from the beginning till the end. Okay. Why am I sorting it? Because I want the absolute differences to reduce now. Okay, so while the low is less than equal to the high, then I will find the midpoint. The mid will be what, guys? The midpoint will be nothing but low plus high divided by 2. Then after that, what I will do is I will write a check function. Okay. Basically in this check function, I'll pass the array, I'll pass X, and what I will pass is I'll pass this particular mid. Okay. If it returns me a true, then in that case, if with this particular cost, if suppose that with this much particular cost, the total cost of the gifts chosen by him is equal to this thing, you have to maximize the total cost of his gifts, right? So if you have to maximize the total cost of his gifts, so Geek will buy the this thing 2 9 and 15. Okay, so 2 9 and 15, the cost of this will be 6. Okay, the minimum absolute difference between any two gifts is 6 only. Yeah, so basically what you will do here is, let's say if it is possible with that particular mid cost, if it is possible to buy, then you want to increase the, then you want to increase your answer, no? So as of now you will store this and you want to increase your answer, so you will do what, low is equal to mid plus 1. If you don't have an idea about this, so what you can do is you can solve problems. There are a lot of problems that you can solve, problems like minimum allocation of books, that is there. Okay, then you can say cocoa eating bananas, cocoa eating banana problem. Then after that, capacity to ship within D days. Then after that, you can have a problem like aggressive cows also. Okay. So if you will solve these kind of like if you don't know about buying such an answer concept, solve these problems and then this will be very intuitive to you. Because if the mid satisfy my criteria now, in that case I will mark my answer as mid and then I will try to increase, because I want to find the max, like I want to find the maximum value now, because I have to maximize my cost. So that is why I'm doing this. Otherwise, if it does not, so I will search on the left side and I will say that my high will be on mid minus 1, and at the end of the day, let's say you will return what, you will return the answer here. And I will write a check function here as well, int check. And let's say what I will have here is int array, and then you will have what, will have int x comma int sorry, you will have vector int ampersand array. Okay, yeah, then after this you will have int x and then you will have int mid. Okay, mid is the basically current cost. So what I will do is let's say initially when I'm iterating, so initially I can say that I will at least take one guy, so I can mark my count as 1. Okay, then I can say that my because I'm starting from, like I'm going to start from the a of 1, because initially I'll mark my previous element as a of 0, so I'll take it by default. Okay, then what I will do is I will iterate. So let's say I starts from what, 1, then I will be lesser than n, then after that we will do an I plus plus, and I will check. What I will check is if the suppose that if what, if the absolute difference of the ith element minus the previous element. Okay, although I don't need to do this, but yeah, so let's like although don't need to take absolute, but still yeah, you can skip taking the absolute because the array is in ascending order only now. So if the a of I minus this thing, if it is greater equal to my mid, greater equal to this thing, then in that case what you will say is that you will increase the counter, right? So you will say that you have taken one more toy, and now for the next time your previous element will be what, your previous element would be the ith element. Okay, and once this is done, then at the end of the day you will check that if the number of toys that you are able to buy, if it is greater equal to x, then you will say that you will return what, you will return true, that with this much cost you are able to buy at least x toys or more. Okay, when this is greater, so it says that like you are able to get at least X or more toys, you can say. What is the commodity given here? This is not toy, but yeah, like gifts basically, right? So if the total count is greater equal to x, so you are getting at least x or more gifts, right? If you are getting at least x or more gifts, so this means this cost is optimal and you want to increase your cost, right? So you will return true. Else what you will do is you will return false here. Okay, this is simple buying search on answer. You can solve problems like minimum allocation of pages and many other problems, and then it will be very clear. Okay, there is some mistake that I have done. Yeah, so let me declare this as a only. So and then this will be a dot size. Let's try and run it now. Okay, so here also there's a mistake. Let's try and run it now, guys. Works fine on the sample, should get accepted. You can do a dry run of it, like this is fine because I'm assuming that you know my search. Okay, so my code is failing for this weird test case. My code's output is this much: 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Okay, I should give one more zero, I guess, then it will work. Yeah, so basically highest was 10 to the power 6 now. Basically this is my search and answer, so you can study about aggressive cows and other problems, uh, allocation of pages, and then you will be clear with it. Okay. Okay, guys, can we move forward to the last problem, because already we are out of, like, we have exceeded the time limit. You can study this. If you don't get it, you can ask me in the comments, I will reply. Take some time, do a dry run. If I see, that is why I spend more time on the second one, because second one was tricky. This is simple template based question. Okay. Can we proceed further, guys? Please write next in the chat. Can we proceed further to the last problem for today? What is the last problem for us? Black tree. Okay, black tree. Please hit the like button, guys, if you are there so far. Then we'll start with the last problem also. Okay, let's have a look at this problem. What does the problem say, first of all? It says that you have been given a tree which consists of n nodes from 0 to n minus 1. Okay, so the nodes are from 0 to n minus 1. Black tree. The name of the problem is black tree. Let's write black b here. Now you are given the nodes from 0 to n minus 1. After that, the tree is given by array parent. Okay, so you are given the parent of the ith node. Okay, basically, suppose that you have got, like, 0 is the parent node, I think. Okay, so for 0, parent of 0 has been given as minus 1, because I think 0 is the root of the tree. Okay, because 0 is the root. 0 is the root. Okay, fine. So suppose, guys, that if you have been given what, like, parent of 1 has been given as 3 here, suppose. Okay, and then suppose parent of 3 has been given as what, let's say parent of 3 has been given as, let's say, 0, and then parent of 2 has been given as what, let's say 0. If this is the scenario, and then suppose that parent of 0 is given as what, minus 1, so 0 will be the root here. Okay, and then you can say that 0 will be the root, and for 0, like, for 0, for 0, what will happen is, one of zero's child will be what, 3, and another child would be 2 here. So in the adjacency list of 0 now, you can put 3 and 2. Are you getting my point? In the adjacency list of 0, you can put 3 and 2, because if you want to make a graph out of it, right? Adjacency list. Then after that, if you see in the adjacency list of 1, 3 is there. So 3 is the parent of 1, so you can say that 3 will point to 1. So this will be the tree. Is that clear? So basically, based on this now, we can build the adjacency list. So you can say that adjacency of 1 will contain what, guys? Adjacency of adjacency of 3 will contain, let's say, 1, because from 3, 1, the arrow is going to 1. Is that clear, guys? Let me use a different color here. Is my screen stuck? So yeah, I hope that I am visible now, guys. Is everything working fine now? Let's see. I think my laptop got updated in the background. Okay. So yeah, I hope it's working fine now. Yeah, so we were discussing about this problem. Let's get back to it. Okay. So yeah, everything is fine. Okay, thanks a lot. If you will see this problem, the node of the tree are either colored black or white, denoted by an array of size n. Okay, that is fine. So either the color is black or it is white. Okay. So whatever the node are colored with black or white. Okay. Black is denoted by 1 and white is denoted by 0. Okay. Now geek will apply m operations on the tree, wherein every operation the node along with its ancestors changes their color. That is, if the color was black, it turns white, and if the color was white, it turns black. The m operations are given by the BRR array. Okay. So let's take this example, or let's take a smaller example for that matter. Suppose that if you have got the parent array, so let's quickly write this parent array here, guys, so that we can see the example completely. If you have got the parent array as what, like let's say you have got -1, 0, 1, and then 2. Okay, and you have got this as 0, 1, then 2, and then 3. All right. So here, what is going to happen? If you have got this thing, so basically you will have 0. Okay, 0 will be pointing to what? 0 is the parent for 1. I guess this is very simple tree, because 1, like 0 is there. Then after that, for 0 the child is 1. Then for 1 the child is 2. Sorry, let me check. So 0 does not have any parent. Parent of 0 is, okay, let me check what is given here. It says that parent of I denotes the parent of the ith node. Parent of I denotes the parent of ith node. Okay. Yeah, so parent of 1 is this. Yeah, that is fine. Then this, okay. So yeah, the tree is like this only. Right. Then after that, what happens is you are also given what? You're also given the uh, normal scenario. Initially, the array looks like this. Initially, the array is 0, 1, 0, 0, 1, 1. Okay. So initially, the array is what? Like the color here is 0, 0, 1, 1. So I guess this is white, white, black, black. Okay. Then after that, what you will do is, it is saying that you will run the query from 3. Okay. So if 3 has been given, like, then after that it says that you will be given the query. So now Geek will apply M operation. In every operation, the nodes along with its ancestor changes their node along with its ancestor changes their color. So they kind of flip their color. Okay. Okay. 1 is for white. No, no. Black is denoted by 1 and white is denoted by 0. No. Ansari. Okay. So what will happen here? If you will see, if this guy is chosen, so for this everybody will change their color. So it will be what? Let me just do it. If firstly you have selected 3, so this will be like 0, then what? 0 and then 1, 1. Okay. Then after that, next time what is chosen, guys? Next time the node that is chosen is 3 again. Okay. So after this, what will the array look like? Now again you will change. So it will be like 0, 0, 1, 1. Okay. So after the first operation, it was like 1, 1, 0, 0. Then after the second operation, it will be 0, 0, 1, 1. Then after that, what will happen is, after that, what will happen is, now the node that is chosen is 1. So this guy is chosen. So this and this would change. So this will be 1 now. This will be 1 now. Okay. So everything is 1. After that, you will choose the guy as 1 again. Okay, so after that, like, no, sorry, you are choosing the guy as 2. So if you're choosing the guy as 2, then because of that, what will happen? These guys will change their color, and now their color will be 0, 0, 0. Okay, so basically, you can see finally the array looks like 0, 0, 0, 1. Now you have to tell that how many elements are what? How many elements are Number of black nodes that are present after applying the operation. So only one black node is there, no? Because this is white, this is white, this is white, this is black. So only one black is present. One black. So answer will be what? I too thought this, sir. Explain with first test case. It has more to do it. It has more to it. Okay. Let's write this test case. First of all, it will be very big, but yeah, let's try and see. So in test case one, what is given? Parent is given. Okay, if this is the array given to you. So what you will do is for 0, like 0, 1, 2, 3, 4, 5. So for 0, there is no parent. 0 is the main father, right? 0 is here. Then 1. Then for 1, this thing. Then for 3, the parent is 0. For 4, the parent is 3. For 5, the parent is 3. Okay, this is how the tree looks like, I guess. Then if I'll color it, okay, this is the scenario. And then what will happen, guys? Okay, so this is the scenario. Let's try and check the case. So you have 3, 4. Okay, so let's write the BRR array here at the top. Okay, so that I don't have to look at it again. So basically you have got 3, then you have got 4, then you have got what? 2, then 3, and then 3, and then what? 4. Okay, so firstly I've got 3. Okay, so this node is 3. So you'll change the color. So this will be what? 1. This will be 0. Then you have got the node 4. So you will change the color of all these guys, right? Starting from there till 4. So what you will do? You'll change the color of this guy, and this guy. Okay. Then you have got 2. So you will change the color for which guys? You will change the color for these guys. So it will be 1, then 1, and then what? 0. Then you have 3. So you will do mark this as 0, and then you'll mark this as 0 also. Okay, then you have got 3 again, so you'll mark this as 1, you'll mark this as 1. Then you have got 4 here. So if you have got 4 here, so you will do what? You'll mark this as 0, you'll mark this as 0, and then you'll mark this as 0. So how many black nodes are there? So basically the color of this guy is 0, the color of this guy is 0, the color of this guy is 1. There's one guy with one black color, and there's this guy with black color. So there are two people which are remaining with black color at the end. So yeah, you can see the answer is 2 here. No? Is that clear, guys? There are two nodes which are having black color. Okay, 5 is one of the nodes that is having black color, and one is like this another node is there that is having black color. So the at the end, nodes 5 and 1 are the nodes that are having black color. Okay, clear? This was a very big test case, to be very honest. Right. So yeah, like when you have to solve this, what you can do, like basically you can apply a basic DFS now. Like you can always have a color array. So initially, like what I can do here is, let's say what you can do is, first of all, initially we can start iterating. So for that, we need to first of all generate our adjacency list and things like that. Okay. And you will see the number of times the flip is applied. Okay. If suppose, see, guys, understand one thing. Tell me one thing. Okay. Like what I am saying is, like, suppose there was a particular node. Okay. Suppose there was a particular node. If I like, and the color of that node was, let's say, white. Okay. 0, that is white. Suppose. Okay. If I know the number of times it has been flipped, so suppose that the number of flips that on that node is suppose 4. So will there be any impact if I am applying 4 flips on a particular node? If there is a particular node, suppose there is a specific node, and I know that on that node I have applied 4 flips. So will that, does that create any impact? Yes or no? Please tell me. If there is a particular node, and on that node if I have applied 4 flips, so what will that make any change in the color? Tell me. Like then you will mark it as 1 0, then what 1 and then 0. Fourth flip will be what 0 ना. सर जैसे रेंज क्वेरी होती है अरे में, ये वैसा ही ट्री में ही है. बेसिकली अंडरस्टैंड दिस थिंग. इफ यू अप्लाई नंबर ऑफ फ्लिप्स on a node, how many number of times? Even number of times. So the color will remain the same. Otherwise the color would change. Okay, if the flips are odd, only then change will be there. Yes, correct. Okay, so this is very important that you need to notice. So we will somehow try to keep the track of the flips also. Okay, and also the color. So let's say I'll declare a color array. Okay, let's say I'll declare it for n+1 size, so that I don't have any out of bound error. And then after this, what I will do is, let's say I will also declare vector int, and then what, after color array, what do I need? I need the flips array, no? Because I need to know how many times the flip has been done. So n+1, 0. Okay. Then after this, what you can do is you can simply iterate. So int I starts from what? 1. Then I is less than n. Then I plus plus. Okay. So because basically for the 0th, the parent has been given as -1. So that is why I'm iterating from 1. So I can declare adjacency list, and I can say that in the adjacency of like you can say that you can have uv pair. So int u is equal to, let's say, I, and then let's say int v is equal to what? Pair of I, right? So you can say that these two are connected to each other. So in the adjacency list of u, you can insert v, and in the adjacency list of v, you can insert u. Like that you can do. That is what we normally do while building our adjacency list. So we can say that adjacency list, obviously I have not declared the adjacency list. So let me declare it vector int adjacency of n+1 size. Okay. Then after this, I will do what? In the adjacency list of u, I will do what? I will push back v. Okay. And then in the adjacency list of v, I will do what? I will push back u. Okay. So this is what you will be doing. And then after that, let's say initially, like, suppose that you have been, suppose guys that you have been given this thing. Okay. So if you have been given what, like, let's say you will build your adjacency list, that is also fine. Now, after building your adjacency list, you can start running a DFS. So suppose that you will start running a DFS, and initially you will always be passing what, like whenever you are running your DFS now, so you will be passing the node. So initially you can start from the 0th node. The parent for the 0th node is what? -1. Okay. Then after that, I will pass the color array here as well. Okay. And I'll pass the adjacency list. And let's say I'll also calculate the number of times the flip has been done. Let's say these things are there that I will have. Now, if I will talk about the color array, right? So color array. So what is the second array telling us about? The second array is having these nodes. Okay. Right. So since the second array is having all those nodes, so we need to think about this, how we can utilize it, right? If the flips are odd, yeah, that is totally fine. So yeah, basically, firstly, suppose that after running your logic, if we write the boilerplate, okay, so suppose that after running your DFS, what you do is, if you will start running I starts from 0, okay, then what, I is lesser than n, then you will do an I plus plus here. And then after this, what you will do is, if suppose that the ith element was 1, okay, and what happens is the flips, the I flip was even. Okay, sorry, the flip was 0. if suppose that you think about the flips, right? So if you have the ith element, okay, and there is an ith element, suppose, and on that ith element, mm, we need to calculate this thing, because when you will go down, right, so you need to know which nodes are there, right? Use XOR operation to flip the bits. Yes, I completely understand that. So if the suppose that ith element is 1, okay, and the flips mod with 2 is equal to 0, okay. So if the ith element is there, okay, and it is 1, so I need to think about it. Okay, and the flips are 0, yeah. So if, like, I need to count the number of bits finally, no? I was thinking that I have to return, but yeah, I need to count. So answer I will mark as 0. If suppose that the ith bit was, like, if the ith node was having the color as 1, okay, and if the number of flips on it are 0, then what you will do? If the ith element was 1 and the number of flips on it are, like, sorry, the number of flips are even, then its color will not change and you will do answer plus plus, okay. Else if what, guys, suppose that ith element was equal to 0, ith node was 0, and the number of flips on it are what, number of flips on it are even, then it will become, like, number of flips on it are odd, then it will become, one, na? That is black, so you will again increase your answer, right? And then at the end of the day I will be returning my count. Is that clear? Like, this is basic logic only, but and add both and modulo. Why do you need to modulo? Like, basically, yeah, you can do it like this now. Why? So basically, if the color was 1 and you are doing even number of flips, so it neutralizes. If the color was 0 and you are doing what, odd number of flips, then it becomes 1. Yeah, you can do it like that, that is also fine. Yeah, multiple approaches are possible, right? Then after that, whatever nodes are there in the brr array, right? What does the brr array indicate here? The brr array is basically indicating, like, okay, so it is given in m, then after that, the total sum of distance from each node in the array of the root is less than this thing. Okay, that is fine. brr array was telling me about the query, no? Yeah. So BRR array is going to tell me about the query also. So whatever element I have in the BRR array, what I will do is yeah, whatever array I have in the BRR array, no, what I can do for it is I can iterate. I start from 0, I is less than m, I guess, if the size is m, then I plus plus, and I can say that I can do color of BRR of I plus plus. Basically what I will do is, now, whichever elements are present in the brr array, for them I will mark their colors like this, okay. So how will this help? So basically, if 3 is there, the node 3 is there, so I am marking all the I'm marking the guy 3 as incremented in the color array. Then after that, what, 4 will be there, okay, so 4 will be incremented, then 2 will be incremented, 3 will be incremented, 3 will be incremented, 4 will be incremented. So the number of times you will be tracing down that node, na, so that I am keeping a track of. Then after this, what I can do is I can run my dfs function, suppose, and I can return value from it. So suppose that I will start a dfs function. Obviously I will pass the current, like, I have the current node, I have the parent, then I also have the color array, right? So what I will do is I have vector int ampersand color. So I've also got the color array, and then I have got what, like, I have also got the adjacency, vector int adjacency, and then what I have got, after adjacency list, I have got flips array also, right? So vector int, basically the number of times I'm going to flip and all that. So flips, right? Now after this, what you will do is like, suppose you are at a particular node. Okay, so int, let's say current color will be what, like let's say it will be the color of the sorry, yeah, let's say, let's mark this as C. So C will be what, color of the current node. Okay, so I will see, I will have a look at what is the color of the current node. Okay, and then after this, like basically the number of times we are going to flip, na, that we will try to update. So the number of times that this node is going to visit it, we will have a track of that. Okay, right after this, so let's not name this as color. Actually, let's name this in some better way. So what can I say? Like, or let's name it as color. Color is basically the number of times you are going to color that path, basically, right? So you are going to color the node. If suppose with respect to the node 5, the value color is 3. So basically indicates that from the root till that particular node, you are going to iterate 3 times. Okay. So yeah, basically the thing is that you will iterate. So you will iterate through all the elements that are present in the adjacency list of that node. So you can say what auto, let's say child is to adjacency of this particular current node. Okay, so you'll iterate through this current node and you will check. What you will check is that if the current node that you are at, if the current node that you are at, if it is not like, sorry, if the child node is not the parent, okay, so except the parent, all the nodes that are present in the adjacency list, you will iterate for them. Okay, and then you will do what, like C is there, then you will do C plus is equal to, you will call the DFS function for what, you will call the DFS function for the child node, you'll pass its parent as the current node, and then you will pass what, you will pass the color array, you'll pass the adjacency, then you will pass the flips also, right? And then once this would be done, so once you have run, like once your DFS will be over for a particular node now, so basically what is going to happen is, suppose there is a particular node. Okay, so from that node till the downwards part, you will try to run, and you will try to cumulatively get, like you will see, basically the thing is that suppose the tree looks like this, suppose, just suppose this. Okay, suppose that it was mentioned that the node 1 will be visited 2 times. Okay, suppose that color of 1 I have marked as 2. Okay, basically if I want that this path will be traced 2 times, and suppose that the color of these guys are initially what, suppose the color of these guys are white and black, let's suppose this. Okay, so what I will do here is now, I'll be iterating and I will start the DFS from this node. Okay, and when I am starting off, okay, so whenever I am at a particular node, so from that current node, I will be running my DFS that many number of times, and I have to cumulatively keep on updating my counter, because if there is a particular node, suppose there is a particular node, like suppose this 3 node is there, and this will be visited, this will be iterated 3 times, right? So if this needs to be like if there is a particular node which will be iterated, that, like suppose that it will, if this path would be iterated 1 time, suppose, right, then for this guy the flips will be updated as what, guys, the flips will be updated as, I guess, uh flips of 0 will be updated as what, 3, because it will be flipped 3 times now, because you are traversing this path 3 times. So basically cumulatively I am taking that part. Okay, and then for this particular current node, I'll update the flip as this cumulated part. So basically from like you will run the DFS for all the calls, like in whichever path this guy is going to come, you will see how many times you're going to change this guy cumulatively, right? Because the number of times my child is going to change plus me now, basically if suppose that it was mentioned, suppose that if it was mentioned that like if suppose that you are going to iterate in this part 2 times and 1 time in this part, so total 0 will be flipped 3 times. So that is what will get updated here, and then for that node it will, the count will get updated. So that is why you are running your DFS for your children, and then once your DFS for the children is over, then you are updating your value, and then at the end of the day, you will return that these many times you have visited. So you are returning that C. Okay. So this is how it will, like this is how ultimately after running the BFS your color would be updated. Sorry, M was not declared. Okay. So M was not declared. So I guess I need to use brr.size here. Let's try and run it again. Are others clear with this part, guys? Please tell me. uh, like basically again this is normal DFS. Basically the thing is that what you are doing is you are like the thing is that you are calling the DFS for all the children. Okay, that will tell you how many times your children are hit. The number of times your children are hit, what does that mean? The number of times my children are getting hit, suppose that 0 is there. Okay, and it has, like, suppose 1 is there, then you have 2. Okay, then you have 3, and then you have 4, and from here you have got 5. Okay, now suppose that this path will be hit 2 times. Okay, like suppose that 4 will be hit 2 times. Suppose that they are saying that this guy is having color 2, this guy is having color 1, this guy is having color 2. Okay, so suppose if you will traverse this path 2 times, so basically like you will update that plus 2 will be contributed because of this element, because you are going to traverse this 2 times. Okay, manipulate this 2 times. Then after that, for this 0, you're going to traverse this path from here to here. So because of 5, it will 5 will return the counter as what? 1. Okay, because you are going to traverse this path because of 5 one time, so plus 1 for that. And then this path, suppose you are going to traverse for 4 2 times, suppose, then what will happen is plus 2 because of 4, because this path is traversed 2 times, so 0 will be hit 2 times because of that, so total number of times will be 5. So that is why for flips of 0 I'll update it as 5. Is that clear? So DFS is basically, for in DFS what I'm doing is you need to understand this, that when I'll be running the DFS now, so while I'll when I return from my child, so it will tell me how many times I had hit it. Are you clear with this part? Suppose guys understand this thing, that if you had 0 here, then you had one child as 1 and another child as suppose 7. Okay, now suppose what happens, you will hit this guy one time. Okay, suppose that there is a scenario that you will hit this element one time. Okay, and you will hit this element 3 times. So then what will happen is, this guy will return, when you will go to this guy will return the count as 3. Okay, and plus this guy, so this will return 4. Total will be 4 now. So now 0 will get updated with the value as 4, because you will say flips of 0 will be equal to 4. Why 4? The flips of 0 will be equal to 4. Why? Because 3 times you are going to traverse this path and 1 time you are going to traverse this path. Right, so that is how it is going to work. Are you clear? Are you clear that after you have after you have run the DFS for all your children, then only you are updating the flips of that particular current node? Does that make sense? Suppose the current node was starting from here. Is that clear, Bankai and everyone else? I hope that this does make a lot of sense, guys. Let's submit it. So like it's like you are running for all the children, and then once you have the total count ready, then you will update that this is the total number of times that I am getting flipped. Clear, guys? Bankai, are you clear and others are clear with this? Okay, so yeah, now we have generated the code also. Yeah, so this was the problem. Is there anyone who is not clear with something? They can tell me. If you're clear so far, guys, please hit the like button, and then we will wrap up the session. Is everyone clear? Okay. So I'm waiting for your responses. If you want to say anything, you can tell me, guys. Okay, so yes, sir. Is bar easy contest? I think it was easy, but it was a little bit implementation heavy for second problem. Else it was fine. Yeah, second problem was a little bit mathematical in nature. Else it was fine. Yeah. So I hope that everyone has understood the contest overall. Thank you guys for joining. If you understood this session properly and you enjoyed the discussion, you enjoyed the idea behind the contest, especially for the last problem, you understood how DFS would be working. So please let me know. Okay, and that's it from my side for today. Thank you and keep coding, guys. Happy coding and GFG karte raho. Bye. Take care.